Hello everyone. First of all, I'd like to welcome you for this webinar session where we are performing the real-time object detection using TensorFlow. So let's get started. We are going to understand what is object detection, and we are going to have an understanding as how it actually works when we talk about object detection. And in this webinar or at the end of this today's session, we are going to perform the object detection. So we are going to perform this task of object detection using the deep learning framework, which is TensorFlow. So first we'll understand what is TensorFlow, and then we are going to perform the object detection task using one of the pre-trained model that is already available to us inside the TensorFlow, and we implement it on an image detection or this object detection task. Okay, so that's the agenda that we have for today's session, guys. So what is object detection? The object detection is actually a task that we do, and it's a computer technology related to computer vision and image processing, which deals with detecting the instances of semantic objects of a certain class, such as humans, buildings, cars, in a digital images or videos. I know this sounds purely technical, but let me make it simpler for you. Object detection means, suppose if I have an object, okay, suppose if I have a digital image, I'll open up an example image for you to make it easier for your intuition. Let me get an image. Let's say I'm having this image or this image with me. Okay, when I'm talking about object detection, I want to identify what is in this image, and I also have to identify where exactly is that object in my image. So when I'm talking about object detection, I'll be talking in terms of two things. So I'll be saying two things. I'll be saying what is present in this image. I'll also be saying where exactly is the position in this image. Now in this example photograph, I can say that, okay, what is in this image? I can say there is a person's face is present in this image. And along with saying as what is present in this given image, when I'm doing the object detection, I'll also be saying where exactly is that person's face. So two things will happen over here. One is detection of what, and the another is detection of where, and both of these things constitutes the object detection. And that's what would happen, or that's what we expect from any object detection model. We not only have to identify what is present, but also we want to detect where exactly is that object is present. I'll give you a simple example, guys, which is relevant for today's scenario. Let's say if I have some like digital image with me. Okay, I'm having some big digital image, or if I have the similar image with me, I'm getting the video feed, and I want to detect whether that person is wearing a mask or not. The reason, because as you know, with the current pandemic, everyone is expected to wear the mask and follow the social distancing so that everyone will be safe, not only the person but also the person around them. So I want to build an application where I want to detect whether a person is wearing a mask or not. So the task that I want to check is whether that person is wearing a mask or not. Okay, now if I want to check whether this given person or given whether the given video feed or given image, whether this person is wearing a mask or not, as a first step, I have to identify whether this given image has a face in it. So I have to first detect whether this given image has a face in it, and if there is a face, I have to detect where exactly is the face in this given image. And once I find these two, whether I'm having a face or and where exactly is that face, then I can check whether this person is wearing a mask or not. I hope you can understand the importance of object detection that I'm talking about. So if I want to do any task by looking into the digital images, be it images or be it video feed, I want to identify what is present in that given object, or what is exactly present over there in a given digital image or the video. And along with that, I want to identify where exactly is present. And that's the expectation, or that's the output that we would get when we perform the object detection. Okay, I hope this gave you some clarity about object detection and what exactly we are trying to achieve when we talk about object detection. Now with this intuition, if you look at the technical terms that is present over in the slides, so you can understand that object detection is a computer technology which is related to computer vision. Now, don't get intimidated by the new terms called computer vision, guys. So this computer vision is actually an ability that we give to the computer to be able to see the outside world. Now, just like we humans see the outside world with our eyes, we'll enable the computers to see the outside world. How can I enable the computers to see the outside world? Exactly. I can see the, or I can enable the computer to see the outside world with the help of camera. So object detection is a computer technology related to computer vision where I'm enabling my system to see the outside world. And once it captures the outside data, it could be either video or it could be images. So I'll process this individual video or image data, and then I'm going to detect that specific instance or that specific image, whether it has objects of certain class. Okay. So this object can be something as whether my given image has humans in it, or whether my given image has buildings in it, or whether my given image has cars in it. So all these things we will be detecting. Now in this example, this is the image that I have given as an input, and I'm detecting what exact like what are the objects that I'm present in this image. So in this example, I'm having a retriever dog, American Staffordshire dog, and there is one more dog. I think I'm unable to see its complete name. So there is another word called another variant of the dog, and this is one more so this is one more breed of dog. So along with saying what exactly is present in the image, I'm drawing the bounding box around it, which says where exactly is that specific object is present. And if you look at the image which I'm having on my left hand side, I'm doing the same thing. I'll just uh, start the slide share again so that you can visualize it. See, I'm identifying what exactly is present on top of my table. So I'm checking like I can see there is a soda can, I can say there is a hat, I can see there is a cup, so coffee mug and everything. I can see everything. Now along with saying as what is present in these images, I'm also drawing a bounding box around it to say where exactly is that object is present. And that's the technology, or that's what we are trying to achieve when we perform the object detection. We are determining what and also where. These are the two things that we'll be doing over here in case of object detection. Now where do we see this application, this application of object detection? One common application, or one application can be is face recognition. So I hope like everyone has experienced this. So if you upload any photograph into your Facebook, so it not only identifies who is present in that image, it also identifies like where is that person's face is present. So it will draw a bounding box around that person, and it is going to ask us whether you want to tag that specific person in your image or not. So that's an application of that's an application of object detection. I'm deciding what is present in the image. I'm also saying where exactly is that object. And with the current pandemic, as we know that we want to follow the social distancing, so we can have the applications where we can identify in a large crowd, so how many number of people are present in this entire crowd. And we can also take a step ahead and measure whether they are following the social distancing or not. So those are some of the examples for object detection. And yeah, another thing can be is like for a given image data or for a given video feed, so what are the various objects that are present over there. Now just for a quick fun activity, you can, like, there's a video that I've come across in YouTube, guys, so which actually talks about how entire world is actually embracing towards this object detection. So there is a video I want to share, how China tracks everyone. So this is one of the video. Just make sure that you watch it and you watch in your free time, and to understand how much close we are going ahead, and where exactly we are going ahead in terms of using various object detection tools. So just to give you an intuition, so in that video they have actually explained uh, how China is actually using their various webcam feed and the various surveillance feed, and they are trying to like they have taken the computer vision to such an extent that they are monitoring each and every individual in each and every place. So to do all those things, they are actually making use of deep learning models, and they are actually performing the object detection over there. You once you watch that entire video, you'll understand the powerful things that we can do with object detection, guys. And another example can be is we can use this computer vision technique to check the industrial quality checking. So whenever something is getting manufactured, so instead of manually validating everything, we can just capture the images and we can have the deep learning model to run through it to identify how exactly like how exactly is it working, or whether is it good, whether the quality of the product that I'm producing, is it a good one or not. And in the recent years, we are seeing another application of computer vision, that is building the self-driving cars. Now in case of self-driving cars, it's a artificial intelligence system which actually observes the outside images. So to observe the outside image, it will actually have cameras around it. So it will have the cameras on top, fixed on top of it, which will be a powerful camera, and which captures the 360-degree video data which are present on the outside. And we will have a deep learning system inside it. it the deep learning system or this deep learning model gets the video feed from this outside camera. It does the pre-processing, and once it does the pre-processing, it identifies, okay, if I have a red signal over there in front of me, so it is able to identify, okay, I'm having a red signal, I have to stop. So that is the prediction that my deep learning model is going to give. And with that prediction, this uh, self-driving car or this system is going to apply the brake so that it stops. So that's one of the application of using the computer vision, guys. Now even in this scenario, we'll be performing the task of object detection, because I'll be capturing the outside world and I'll be seeing what is present in that given image and what is the information that it is trying to tell me. Now with that analysis, I'll be taking the action. And another example is security. So uh, like we can use this computer vision application to identify whether the person is following the security protocol or not, or whether this person is a valid person or not. So all these things can be the or are the applications of computer vision and the object detection, guys. Now when I'm talking about computer vision, it's the whole topic, guys. Like inside the computer vision, we have various tasks, so object detection, image classification, and many things. So under that computer vision, we have the subtask of object detection. So don't get me confused when I'm using both the words uh, like interchangeably. So both would mean the same thing. So I'm using the computer system to capture the outside world data and give the analysis to me. Now let's look at the workflow of object detection. So if I want to perform any object detection, so we actually are going to follow some key steps. So some key steps can be is if I want to perform any object detection, I'll need to have a data. So I need to have a data. I'll use some data with me which is already present. Suppose if I'm trying to classify, or suppose if I'm trying to identify whether my given image has a cat in it, and if it is a cat, I want to draw a bounding box to represent where exactly is the cat. So what we do in such scenarios is, as a step one, we are going to get the data. So the step one is get the data. So when I say get the data, I'll collect the data from the outside world. I can collect the data. There are various sources, guys. I can use my existing business data, or I can collect the data from open source. So if the open source is not available, I can uh, employ some Amazon Mechanical Turks. I can use this service, and I can have real people to get the data for me. And or I can make use of Amazon image labeling service that they have. And I can just AWS. So when I say Amazon, it's actually AWS, guys. Okay, AWS image labeling technique services that they have, and I can use all these services, and I can get the data. Now, when I'm talking about getting the data, what exactly is the type of data are we looking for? Now, suppose the task for me is to, for a given image, let's say this is a given image, this is an image which contains uh, tree. Now let's say for this given image, I want to identify what is present in the image, and I also have to identify where it is present in the image. So if I want to identify both, that is what and where, then my training data, so if I want to detect what is present in the image and where exactly is present in the image, then my training data should basically have these two things. So if I'm building an image classifier, or a classifier which can actually detect whether my given image has an image of cat or not, and if the cat is present, where exactly is that cat, then my training data, so my training data will have the image. Now, along with this image, I want to have what is present in the given image. So an example can be as cat. And I also have to have the bounding box coordinates, which says as where exactly is that cat is present. An example can be something as I can have x comma y comma h comma w, which is nothing but, suppose if I draw a bounding box, I'll choose a different color. So x comma y represents the, let's assume this is the x comma y it represents, and I should have width, and I should have height. So my training data, that means the data that I'll be using, it should have the image of that cat or image of the object, and it should say what is present in that image, and it should also specify the bounding box coordinates. Okay, so these are the things that I need to have in my data. Now, once I have the data, let's say I'm building some classifier which detects whether cat is present. Similarly, I'll be building a classifier whether a dog is present. So likewise, let's say I'm building a simple object detection classifier which says whether my given input image has a cat or a dog. And if any of this is present, it's also going to give me bounding box. Then I'll be having a set of data which contains images of cat and images of dog, and each and every individual image will have the label which says what is present in that given image, and it also says where exactly is present in my given image. Now I'll be using all this data. Now using all this data, I'll be making use of my deep learning neural network. Okay, I'll make use of my deep learning neural network. And using this deep learning neural network, I'm going to train this model such that it learns it learns to identify what is present in the image, and it also it also learns to identify where exactly the object is present if it identifies what. So that will be the common flow, guys. So we'll have the data, and we will pass this data to the deep learning neural network. We perform the training, and once we perform the training, we'll make sure that the deep learning model that we train, so it will have the ability to identify what is present in the image, and also it can identify where exactly is that given object, or where exactly this what is present in my given image. Okay, now while performing the training, so we make use of various network architecture. I can make use of CNN or any other models. So I'll make use of many network architecture, various network architecture, do the hyperparameter tuning, and do all those things, and I'll complete the training. And once I have the trained data, I can send a new image. Okay, I can send a new image, and an example can be something like this. Let's say once I've done the training, I'll be sending this data, this new image data, to my deep learning model. And once I send this new image data for my deep learning model can say what is present in the image. It is going to say it as cat, and to say where exactly it is present in the image, it's going to give us the x, y, h, and w. That means the bounding box coordinates, x comma y, and this is the height, w width, and this is the height. So that is what my deep learning model is going to give me. Now, as a part of today's session, we will be making use of pre-trained model. So when I say pre-trained model, I am having a deep learning neural network which is already trained. So I'll use this already trained model, and I'm going to show you as how we can use this already trained model, send in the data which is already with us, and then we can get the predictions of what are the things that are present in my given input image. So that's what we are going to cover in today's session, guys. Now, to perform this, that is to use this pre-trained model and to send the input data and to generate the predictions, we will be making use of TensorFlow. So TensorFlow is the deep learning framework that we will be using. Okay, and this TensorFlow is a deep learning or an open source machine learning platform created by Google, and this is one of the go-to tools now to perform any deep learning relevant task. Previously we were using the PyTorch, and now we are shifting most of our work towards TensorFlow because it is backed by the Google, and it has very good support for mobile and many such remote devices as well. And because of that reason, we are seeing most of our applications or deep learning applications getting deployed using this TensorFlow open source library. Okay, so that's how we proceed along, guys. So let's go to the slides and let's walk through the slides now. Now, whenever I want to perform the object detection, so I'll have my training data. In this example, I'm trying to understand whether a given image has a car or a bike. So I'll have images like this, and on top of my image, so I'll run the uh, learning. So I'll learn, like I'll use my deep learning model, and I'm going to understand the various features that are present in each car and bike. So this process constitutes the training of deep learning model. And once we have done the training, we will have the trained model which can identify whether a given image belongs to either a car or either a bike. Now, once I have trained my deep learning model, I'll use the trained deep learning model for testing it with the new data. So let's say this is the new data that I'm having, which I have not used during my training. I'll send this new data. I'll send it to my trained model, that is this trained model, and I'll be able to generate the outcome which says as, okay, this this input image belongs to the class, or it belongs to the class of this bike. So that's how a typical object detection flow will be. So this is actually talking about classification, and once we have done that, we can also draw a bounding box around it and say where exactly is that given object. Okay, so this is just a overall view as how the training will be. Now, coming to TensorFlow, as I mentioned already, it's the deep learning framework that we have, which has been created by Google, which we'll be using to create the deep learning models. So this TensorFlow has one of the main object type that is called as tensors. Now, when we are working with TensorFlow, we are going to have all the objects into the data type of tensors. And this tensors is actually a standard way of representing the data whenever we are performing the task of deep learning. Now, this tensor is very similar to NumPy arrays, but the way it is going to give us an advantage compared to NumPy array is by making use of tensors in TensorFlow, it is going to help me in tracking the operations. And by tracking the operations, I can directly perform the auto differentiation on top of it so that I can make use of those gradients to update the values in my parameters. And not only that, by making use of tensors, we can also get the speed boost, because using these tensors, we can have the computation run on the GPU rather than the CPU. So by running on GPU, it has been shown that we are going to get the speed boost of close to 10 times the speed that we could get on CPU. And because of those two important reasons, we'll be representing all the data in terms of tensors while working with deep learning. Now this tensor, as I mentioned, it's similar to NumPy array. It's a multi-dimensional array, and it's an extension of two-dimensional tables matrices to data with higher dimension. It's a multi-dimensional array, guys. Suppose if I have a vector, I can say that tensor of dimension 6, which is a single dimension vector or a single dimension tensor. And if I have a two-dimension tensor, I can say this is a tensor of dimension 6, 4, so 6 rows and 4 columns. And if I'm having 3 dimensions, so this is a tensor which has 3 dimensions, which is having the shape as 6, 4, 2. Okay, so this is the basic representation, or like these tensors are the objects through which we represent the given data. Now in TensorFlow, as I mentioned already, so like in TensorFlow, the computation is approached as a data flow graph. So what it actually means is each operation that I'll be performing with the help of my tensor object, it's going to track it. Now by tracking it, I can directly go back and perform the back propagation, which will directly help me in finding the derivatives for the complex equations, because it is automatically tracking by its end. So because of that advantage, we'll be using this TensorFlow, guys. And so what we do in case of TensorFlow is we'll have the input data, and we'll send it to the TensorFlow, and we'll perform the training on the TensorFlow model. And once we perform the training, we will have the train model with us. And once the training has been completed, we can just send in the test data, and we can validate how exactly are we getting the result. So like this is the typical flow that we would follow. Like we will have the train model with us. So we will have the input data. We'll use the input data to perform the training. And once we perform the training, we will have the model trained for us. And once the model is trained, we can send in the new data. And if I'm doing the task of object detection, when I send a new data, I'm going to get an output that would look like this. So it is going to identify what are the objects that are present in the image, and along with that, it's going to draw a bounding box which says where exactly is that object is present. Okay, so this was about using the TensorFlow for performing the object detection. So with this understanding, let's go to our Google Colab notebook and let's implement it in a hands-on manner, guys. Now here, as I mentioned already, we'll be making use of TensorFlow. So this is going to take care of installing my TensorFlow. So I'll normally have the TensorFlow. This is to make sure that I'm having the required version. So in my case, I want to use the version of TensorFlow 2.2. Hence, I'm just installing that TensorFlow 2.2 version for this instance, okay, which is my Google Colab instance. So this is going to take care of all the necessary installations. And once I've done the installation, I'm just creating a folder for me. Okay, so the folder would look like this. So I'm importing the OS library, and I'm importing my pathlib library, and using both of this library, I'm just checking whether I'm having the let me do one thing. I'm going to restart the runtime so that you can understand what exactly is happening over here. So this will reset all the uh, progress that I had till now. So this is going to assign me a fresh copy of system. Okay, so this is a fresh copy of the system that has been assigned to me. And here, while make sure that you have switched on the GPU. So to switch on the GPU, go to Edit, Notebook Settings, and select the hardware acceleration as GPU and click on Save button. Now by doing like this, you'll have the access to the GPU, that is graphical processing unit. So I have the fresh Google Colab instance that has been assigned to me, and this has the RAM of 12.69 GB and the hard disk space of 69 GB, and I have already utilized 38 GB of hard disk. Okay, so this is the Google Colab instance that has been assigned to me. Now I'm going to install the required version of TensorFlow. Now, as I mentioned already, to perform the task of object detection, we'll be making use of pre-trained model. Now to make use of pre-trained model, as a first step, we have to create the we have to get the clone from the GitHub. So from this clone of TensorFlow models, we have to clone it. So I'm going to copy that URL and I want to show you over here. So this is the TensorFlow model garden, guys. And if I want to perform the object detection to with any of the pre-trained model, I have to first clone this repository. So this code is going to clone the repository from this GitHub link. Okay, so hence I've given as git clone and I've given the models folder. So from this models folder, it's going to create a clone, guys. When I say it is going to create a clone, it is going to copy everything that is present in this GitHub link. Okay, so you can observe the same uh, in our left side as well. So on our left side, we have actually the file explorer. Currently I'm having only single folder called sample data. Now I'm going to okay, let's wait for the completion of the installation over here. So this is taking a while for me to install the TensorFlow 2.2 version for me, so let's wait. Okay, so it has installed the required version of TensorFlow for me. Now, once it has been installed, here in this cell, I'm creating a clone from this GitHub link. So I'm going to execute this cell. So once I execute this cell, so it's going to connect to this GitHub URL and it's going to create the clone. See, if you just observe, it has created a folder called models, and if I expand this folder of models, I'll be having various subfolders: community, official, orbit, research, and so on. See, if I open the models, I'm having various subfolders: community, official, orbit, research. So all these things has been copied over for me. That means all these things have been cloned for my working. Now with this GitHub uh, models folder cloned, the next step would be is we want to make sure that we like all the system requirements will satisfy for us to make sure that we can work with the object detection API, which is our pre-trained model. Now to check whether everything is installed or whether we have all the dependencies with us, so we just have to run this cell. So this cell is going to make sure that it is going to create all the dependencies which are required for us to run, and along with that it is going to set up a system so that we can make use of all these pre-trained models. So I'm going to execute this cell, so please bear with the execution, guys. So since this is a object detection which is a complex model, it would take a while for system to get ready. So this is going to uh, like verify everything, whether every library is present for me, and once it verifies everything is present, it is going to set up a system so that we can directly run that object detection API. Now by the time it runs, let's explore this GitHub screen that we have over here. So here, if you observe, it says the TensorFlow model garden. It's a Tensor model garden for TensorFlow, and it says how you can use this TensorFlow model garden. And apart from this, there is one more link. Yes, there is one more URL which I want to share it with you, which is called as object detection TensorFlow. So I'll add it over here. So this URL contains the information of various object detection APIs that are available to us inside the TensorFlow. Okay, and if you come down, it actually talks about what are the individual models that we have inside our TensorFlow. So all the individual models inside the TensorFlow which are available to us is present inside this TensorFlow 2 model zoo. So this is the TensorFlow 2 model zoo. And if I click on that URL, you will be redirected to this URL, guys. This is that URL. And these are the various object detection models that we have, and which has been given directly to us by the TensorFlow team. And all these models that you're seeing, so these are the object detection models. So these are the object detection models, and these models are already pre-trained on 𝐶𝐞 2017 dataset. If I open the information about this 𝐶𝐞 2017 dataset, so this is a dataset which is actually used for performing the object detection, and this has around more than 1 million of images, guys. So all these models that we have, it has been trained on this 𝐶𝐞 2017 dataset, and it is already pre-trained for us. We can just use this trained models, and we can do our own prediction. That's how easy it is for us to work with TensorFlow Model Zoo, guys. Okay, in our scenario, we'll be making use of what we call as uh, image efficient DNet. So I think this is the one, efficient det DeFi. So this is the pre-trained model that we'll be using to perform the object detection in our case. Okay, so here in this cell, I'm just importing all the necessary helper functions. So once I am importing all the necessary functions, I've just written the helper function which will help me to create a plot. So this is going to create a plot. That means it's going to pre-process the image, and it will help me to create a plot. And along with that, I'm just uh, creating a label map, because as I've already mentioned, this this model that we have, that is TensorFlow 2 object detection models, this has been trained on 𝐶𝐞 2017 dataset. Now to add a name for each and every image that I'll be using, I'll have to create a label map. Hence, I have created a label map in the form of a Python dictionary. This is going to take care of it. So in this way, I'll be creating my category index, and it will have its ID as well as its name like this. So this will take care of defining the helper function as well as defining the various classes that we have. And here, this cell is actually going to download the saved model, and it is going to add under this folder of models research object detection test data. So I'll open the folder path for you to show you where it will be saved. So models research object detection, and in this folder I'm going to create a folder called, there is a folder called test data, and inside this folder we are going to download the file, which is a pre-trained model file from this URL. So this is going to download the pre-trained model, and once I download the pre-trained model, I'm going to extract that zip file, which is in actually tar.gz format. So I'm going to extract it, and then I'm going to move everything to this subfolder of this test data, guys. So I'm going to execute this. So this is going to take care of downloading the saved model from the URL. That means it's going to download from this TensorFlow object detection, download from this model zoo. And once I have everything, I'm going to have it inside my test data. See, under the subfolder of test data, I have created one more subfolder, which is called as efficient det DeFi, and which has been trained on 𝐶𝐞 dataset. So we have the pre-trained model with us. So what I have already done over here is I have downloaded the pre-trained model for me. So this is where we are currently. So we have downloaded the pre-trained model. Now once we have the pre-trained model, which is a model which has been already trained, we can just send in some test data which is already with us, and we can generate the predictions. So to generate that, here in this uh, here in this thing, like before I do that, I'm just loading that model into my TensorFlow instance. So to load the model, I'm just writing as tf.saved model.load. So this is going to make sure that it will load the pre-trained model for me. So once I load my pre-trained model, I'm going to select some test images. Okay, so there are some images which is already available to me inside the subfolder of test images. So this is the subfolder of test images, and there is an image 1, image 2, and image 3. So if I download any single image, so if I download this single image, So this is a one image that I'm having with me. Okay, I'm having an image of dog, and this is another image that I'm having with me over here. So I think this is an image of beach, and I'm having one more image. So this is an image of various tools that I'm having in this given image. Okay, so what we can do is we can, since we already have the pre-trained model, we can just go ahead and load load these three images which are present inside our test folder, and we can generate the predictions on top of each of these image. So I'm going to execute this cell, guys. So this is going to load each and every individual image, and it is going to run the detection on all this input image, and it's going to show us as how it's going to show us as where exactly each and every image is present for us. So this would take a while for generating the predictions. Okay, so we have the results for us. So there was a typo error, guys. Here I had given us for I in range 3, and normally when we call range function and when we give the value, so the input value starts from 0, but here I'm having only 3 images, but I was going through 4 times, so hence I was getting the error. So make sure that you correct this error if you are working over there. Just give it as for I in range 2. So this will load every image for us. So for the first image, it has said this image contains 3 objects. So one object belongs to the person with the confidence of 78%, and the another object that we have over here is dog with the confidence of 83%, and this is another object that is with me which is having the confidence of 83%. So this is second image it has loaded. So it has loaded that uh, this is the image that it has, and this image has kite with 54%, kite with 56%, kite with 89%, so person with 87%. So what we have done over here is we have just ran through every image that we had over here from our test data test folder, and then we have just created like we have also detected the objects that are present. So to summarize, what we have done as a part of this today's session is we have seen what is object detection. So object detection is a task in the field of computer vision, and when we talk about this object detection, we want to identify what is present in the image, and along with that I want to detect, or I want to say where exactly is present that specific object that I'm trying to say what. Okay, what and where, both are the things that we will be getting when we are doing the task of object detection. Now to do this, in this specific session, we have actually made use of pre-trained model which is available to us from the object detection API of TensorFlow 2, and one such model is efficient D5. This is the research paper of efficient D5. So we use this pre-trained model, and using this pre-trained model, we have chosen some of the data which is already present with us inside our folders, and we have ran the object detection. And once we ran the object detection, we were able to see what is present in a given image, and along with that we were also able to draw the bounding box to say where exactly is the given object. And that's the beauty of object detection, and we were able to do all this compound like complex things with very few lines of code. And that's the powerful, or that's the power of TensorFlow. It will help us in uh, gaining, or it will help us in getting the boost from making use of pre-trained models instead of training everything from scratch. So this is about performing the object detection using TensorFlow using pre-trained models, guys. Okay, so with this, we come to the end of today's webinar on performing the object detection using TensorFlow, guys. Thank you, guys. Bye.